In this new unit, domain and range are going to be very important. So we're going to quickly review some of the concepts that you saw way back at the beginning of this course. So we're going to focus on domain. There are two things that can break a domain. The first would be if you're taking an even root, like the square root of something, for instance. If I had the square root of x, well, x could be 0. It could be 1, it could be 2, but I have a problem if x is like -4, because the square root of -4 we know is now in the complex number system. It's non-real. So if I have an even root, like a square root or a fourth root, I have to make sure that my radicand is positive. So in this scenario, I'm going to have to say that x is greater than or equal to 0, or in interval notation, all the numbers that are good here would be 0 all the way to positive infinity. I also have to be careful if I have fractions, meaning if I have a variable really in the denominator of a fraction. So if I have a function that's like y equals 2 over x, x can be anything, but I have a problem if x is 0 here, because 2 divided by 0, we know that's undefined in mathematics. So I've got to say that everything's cool as long as my domain is not 0. In interval notation, that would be from -infinity to 0, union 0 to positive infinity, showing that everything but 0 is included. Let's find the domain of f of x here. So 2 minus x to the 1/2 power is equivalent to the square root of 2 minus x. The the exponent of 1/2 means that the index is the same as the denominator of that fraction. So the index here is 2, the square root of 2 minus x. So I have a problem if I have a negative radicand. So I'd be fine if x were 1, because 2 minus 1 would be 1. I'd be fine if x were 0. I'd be fine if it were negative. I'd even be okay if it was 2. 2 minus 2 is 0. But if it's 3, I got a problem, because 2 minus 3 would be -1, and I can't take the square root of -1 in the real number system. So when you're given an even root, the easy thing to do is take your radicand, 2 minus x, and if you just kind of write this off to the side, you got to say it's got to be a positive number. So you write it's greater than or equal to 0 and solve it. Add x to both sides, and that gives me 2 is greater than or equal to x, or I could rewrite it as x is less than or equal to 2. So my domain would be, in interval notation, -infinity to positive 2. Now, to understand the range, one of the easy things to do is put this in your graphing calculator. You can see that I just did that. And I can see the lowest the graph goes is 0, and it goes infinitely upward. So my range is going to be 0 to positive infinity. Let's look at g of x is equal to -5x. Well, this is linear. You should recognize that, and all lines have a domain and a range of all real numbers. Additionally, it doesn't break our domain with either of our rules. We don't have a fraction, and we don't have an even root. All right, let's look at h of x, which is 4 times the square root of x plus 3. So again, I have a radicand here. So I'm going to look at this x plus 3 and think about what causes a problem. I can't have a negative radicand. So if x were -3, that would be 0. So again, if I just take my radicand, the x plus 3, I don't need to worry about that coefficient of 4 and say that it's got to be greater than or equal to 0. Subtract 3, I recognize that x has to be greater than or equal to 3. So my domain would be -3 to positive infinity. Again, I am graphing my function for you to see the range. So the range is going to start at 0 and go to positive infinity again. Number 4, t of x is equal to the cube root of -x. Well, the cube root function has no restrictions. The domain is all real numbers. If you look at the graph, you would see that. But also, if you just think about it, you can take the cube root of a negative value, positive value, or of 0. So my domain and my range on this one are all real numbers. So in interval notation, it's going from negative to positive infinity. That would be the same for any radical with an odd index, like the 5th root, 7th root, 11th root, etc. R of x is equal to 3 over x minus 1. So this time I have a fraction with a variable in the denominator, so I've got to think about what x value would cause the denominator to be 0. And I believe if x is 1, I have a problem. So I'm going to say x can't be 1. What you can always do if you're confused is take your whole denominator and say it can't be 0 and solve for x, and you would get x can't be 1. So when I write my domain for this one, it's going to be negative infinity up to 1, but 1's not included. It gets really close to 1 on either side. So that's how I would write that. Now, my range on this one, until you get see enough of these, you definitely want to take a look in your graphing calculator at what they look like. This one, interestingly, has something known as a horizontal asymptote. So I just graphed this, and you can see it's interesting. It's called a hyperbola, and it gets really close to the x-axis over here, and it gets really close over here. We can also see it never ever touches this x equals 1 value. So the range is going to be everything except for 0. And for now, the only way you're going to recognize that is, again, if you toss it in the graphing calculator. So I'm going to write my range where it's everything except for 0. But honestly, the focus presently is on the domain, but the range is great practice. All right, last one we're going to look at here is p of x is equal to negative 4 over 2x plus 3. So here I've got a denominator. So I'm thinking, okay, what's going to cause a problem here? Some of you are quick with your mental math and might see that it's negative 3/2. If you can't see that, take your whole denominator and say it can't equal 0. So we subtract 3 and then divide by 2, and I get x cannot equal negative 3/2. And now if I look at the graph of the function, I can again see I've got this graph scenario where it's approaching 0. Never quite touches it. It's known as a horizontal asymptote. So everything except for 0 is included in the range. Okay, reach out with any questions that you may have.